Hey everyone. So I thought I'd put together a little video showing a more practical example of putting together a bunch of the different things that we've learned to write some somewhat more real-world code. So the example I have in mind is a function frequencies that takes a string and gives us a map that tells us for each character that occurred in the string what fraction of the time did it occur. Okay, so rational, there's a built-in rational type in Haskell in the Data.Ratio library, the Data.Ratio module. So I have another version of this file with a solution already in it, so I can just show you what it should do once we've implemented it. So for example, if I give it the string banana, so I get a map. Basically, this is just showing us all the key value pairs in the map. That's how it printed out. So the key A has the value 1/2, B has the value 1/6, and N has the value 1/3, right? Because half of the letters are A's, 1/6 are B's, and 1/3 of the letters are N's. Okay. So how are we going to write this function? The first thing that I would think of is that we should first just count all the letters. And then after we're done counting, we can go through and divide them all by the length of the string. So let's, before we even write the frequencies function, let's make a count function that gives us a mapping from characters to the number of times that character occurs. So, and this is a pretty frequent technique in any language, but especially Haskell. If we want to write some function, let's break it down into smaller functions until the functions are not too hard to write. So this one I think we can write directly. So let's pattern match on the string. So if it's the empty string, we're going to get the empty map. So m.empty. And if it is a string which is a cons, so it has a character C followed by the rest of the string C's. What I want to do is, well, I want to recursively count C's, but then I'm going to get a map from that, and I just want to add 1 to the count for the character C. But if C wasn't already there, then I'm going to create it with the count 1. So actually, there's a function in the map module that can do this for us. So if I just said m.insert, so this is not correct because this is going to replace whatever value was associated with the character C with the value 1. So you can actually see if I load this and say count banana, I'm just going to get a count of 1 associated to each letter. However, there is a function called insert with that takes an extra function that says if that key was already there, how should we combine this value that we gave it with the value that was already there before? And so we want to say, yeah, just combine them by adding them together. And so this is going to do the right thing. Yeah, so now we get a count of 3 for A, 1 for B, and 2 for N. Okay. Now before moving on to finish the rest of frequencies, I want to spend a minute looking at this count function that we just wrote. So if you look at the structure of what we wrote, right, we're pattern matching on a list, and if it's the empty list, we do a certain thing, and if it is a cons, we recurse on the rest of the list and then do something to combine that first element with the result, the recursive result on the rest of the list. So this is exactly a fold, right? This is a fold on the list. So we could actually, that's an explicit way to write it, but we could replace this by saying count is going to be, or I'll say count C's is foldr. So I have to give it the combining function first. So this is going to say given our character C and our map M, we're going to say m.insert with plus C1M. And then we have to tell it what value we want for the empty list. That's m.empty. And then I'm going to fold the list C's. Okay. We can simplify this still more. So for example, I don't actually need to write C's on both sides. So this says to do count on a list C, on a string C's, you do this function on the list C's. But I could just say count is this function. So I can, right, this is called eta reduction. We talked about this, I think, I mentioned it with lambda calculus. So count is the function that does a foldr with this combining function and m.empty as the starting value. And we can actually do the same thing here. So notice this lambda has an m as an argument, and it just calls this on m. So we can further simplify this and say like that. Okay. I can't actually get rid of the C. Because the C doesn't occur as the last argument to this thing, I'd have to do some awkward things with flipping function arguments. So you could do it, but let's not bother. So that's pretty good. That's nice and concise. So let's, the other thing we have left to do, right, is that once we have this map of counts, we need to go through and divide through by the length of the string. We could just, well, we'll do it here. So we want to say, we first do count s, and we want to take that resulting map and divide every value in there by the length of the string. So that, of course, that's an fmap. I was going to say a map, but that's confusing because we have a map. We are doing an fmap operation where we're applying a certain function to every value in the map. The function we want to apply is the divide by the length of s operation. You know what? I just realized we should make this integer just because the rational type is defined in terms of integers, and then we don't have to convert anything. So I want to say fmap the function that says divide by. Now when I say divide by, I'm going to use a %, which is the constructor for rationals. So length of s. Actually, length of s isn't the right type because it's an int. So I need to say like from integral length of s. Apply that to count s. So this doesn't work because I have a parse error, apparently. What is wrong? Oh, I'm missing a parentheses there, okay. Okay, and let's try it. Frequencies, banana. That works. Now, another thing we could do, just to show an alternative way of doing this, we could also make a function to normalize a map. So it just says take a map A integer and turn it into a map A rational, where we add up all the integers in the map, and that'll give us our total size. We want to divide them all by that total. So I want to say something like well, we need a way to take all the values from the map and combine them all. So one thing we could do actually in this case, let's go to hugel.haskell.org. I don't know if I've mentioned this before, but it's a nice little tool. In particular, I want a way to get all the values out of a map. So I can say, hey, is there a function of type map ka to a list of A? And yes, indeed there is. It is the elements function. So I can say fmap. We're going to divide by, instead of the length of some string, we're going to divide by the length by the sum of all the values in the map. So the sum of elements m. I'm going to map that over m. So I could also define frequencies as, so let's make a different version here. I could define it by saying frequencies2 of s is you normalize the count of s. And of course we could realize that this is just the composition of normalizing count, so an even better way to write this would be to just say frequencies2 is normalize composed with count. And let's check it. That should work too. That works the same way. One other final thing I'll point out is that actually it turns out that we don't even need to ask for the elements of m and then sum them. The sum function is very generic, and it applies to a lot of different kinds of data types. So we can just ask for the sum of the map, and we'll automatically get the sum of the values. So just reload this and rerun it. It still works. And well, so actually map is an instance of a type class called foldable. That's why you can do sum on it, and I'll let you look that up if you want. So you can look up the foldable type class. You can find it here in the data.foldable module. I'll let you look at that if you want.